A new functionality added to Flownex is the ROM Builder. The ROM Builder is a reduced order model builder that generates a multi-platform enabled FMU. A FMU is a functional mockup unit that could be used by other software programs to solve simulations concurrently with Flownex. The ROM Builder makes use of machine learning and neural networks to generate a FMU that predicts outputs for a given set of inputs. This reduces the amount of processing power and time needed to run a simulation. It also eliminates the need for Flownex to be installed on the computer which the simulation is run. The neural network is trained by means of a sensitivity analysis within Flownex for different inputs and outputs within a desired range. After the neural network has been trained, one can test and review the predictions made by the ROM against actual results calculated by Flownex. For an example of how to configure a ROM builder, we will look at a simple pipe network with boundary conditions at both ends of the pipe. To set up the ROM builder, click on the configuration ribbon at the top of the screen and click on the ROM builder setup. A window will appear where you can configure the ROM builder for different inputs and outputs with the neural network setup. The first block on the top left shows the different ROM models configured and the status thereof. It also shows whether the model has been trained or not and the number of samples used. As you can see, the current ROM model has been trained with 100 samples. Add the desired inputs and desired ranges to the results under the sensitivity analysis section. For this example, the inlet pressure and inlet temperature were used as the inputs. For the results, the mass flow through the pipe as well as the outlet temperature were used. Specify how many sensitivity runs the builder should use to train the network. To start the sensitivity analysis, you can click on the Generate and Overwrite button, which will generate the data that will be used to train the neural network. The hyperparameters for the neural network training at the top right can be changed to achieve specific correctness of correlation. One can read up on these parameter functions in the Flownex manual. After setting up the hyperparameters, you can click on the Build and Train button. The ROM Builder will then start with the neural network training. After the ROM Builder is finished, you can use the results versus inputs or predicted versus actual plots to investigate the accuracy of the ROM model. With the results versus inputs plot, the relationship between the input variables and output variables will be displayed in the graph. This will compare the actual values obtained from Flownex and the predicted values obtained from the ROM model. If you see a range where the error is large, in this case between 150 and 152 kPa, you can redefine the range of the input parameter. Then by selecting the Generate and Amend option, the ROM model will be retained in the newly specified region to improve the predicted value's accuracy. The predicted versus actual plot displays the correlation between the calculated results obtained by Flownex and the predicted results generated by the ROM model. Lines of different percentage errors are displayed to easily spot large errors. As you can see, the percentage error for the ROM model created here is smaller than 5%. As mentioned previously, more information regarding the ROM Builder can be found in the General User Manual under the Help tab. Learn more about Flownex at www.flownex.com and join our discussion on LinkedIn and YouTube.